Building a Python stock price prediction app, a comprehensive guide. Disclaimer: stock price prediction is a complex task and involves significant risk. This response provides a basic framework. Always conduct thorough research and consider consulting financial experts before making investment decisions. Understanding the components. A stock price prediction app typically involves the following components. 1. Data acquisition. Fetching historical stock data from reliable sources like Yahoo Finance, Alpha Vantage, or Quandl. 2. Data preprocessing. Cleaning, transforming, and preparing data for modeling. 3. Feature engineering. Creating relevant features from raw data. 4. Model selection and training. Choosing suitable algorithms, e.g., LSTM, ARIMA, random forest, and training them on the prepared data. 5. Prediction generation. Using the trained model to predict future stock prices. 6. Visualization. Displaying historical data, predictions, and other relevant information. 7. User interface. Creating an interactive interface for users to input stock symbols, select prediction horizons, and view results. Python libraries. Several Python libraries are essential for this project. Data acquisition, pandas_data reader, yfinance. Data manipulation, pandas, numpy. Visualization, matplotlib, seaborn, plotly. Machine learning, scikit-learn, TensorFlow, Keras. Web framework, Flask, Django, Streamlit. Basic code structure. Here's a simplified outline of the code structure. Building a web application. For a user-friendly interface, consider using a web framework like Flask or Streamlit. Streamlit is particularly popular for data science applications due to its simplicity. Key considerations. Data quality. Ensure data accuracy and completeness. Feature engineering. Experiment with different features to improve model performance. Model selection. Choose appropriate models based on data characteristics and prediction horizon. Evaluation. Use metrics like mean squared error, MSE, mean absolute error, MAE, or root mean squared error, RMSE, to assess model performance. Overfitting. Avoid overfitting by using techniques like regularization, cross-validation, and early stopping. Time series nature. Consider time series specific techniques and libraries like stats models. External factors. Incorporate economic indicators, news sentiment, or other relevant factors. Deployment. Explore deployment options like Heroku, AWS, or Google Cloud Platform. Additional tips. Start with a simple model and gradually increase complexity. Experiment with different hyperparameters. Use cross-validation to evaluate model performance robustly. Visualize data and predictions to gain insights. Continuously update your model with new data. Remember, stock price prediction is challenging and involves inherent risks. This code provides a basic foundation, but building a robust and accurate prediction system requires extensive experimentation, domain knowledge, and careful evaluation. Would you like to delve deeper into a specific aspect of this project, such as data preprocessing, model selection, or building a web application? Let's break down the code line by line. Note: without the specific code you're referring to, I can provide a general explanation of each line based on the common libraries and functions used in stock price prediction. Import statements. Import pandas as PD. Imports the pandas library, aliasing it as PD for easier use. Pandas is used for data manipulation and analysis. Import numpy as NP. Imports the numpy library, aliasing it as NP. NumPy provides support for large, multi-dimensional arrays and matrices, along with high-level mathematical functions to operate on these arrays. Import matplotlib. Pyplot as PLT. Imports the matplotlib library's pyplot module, aliasing it as PLT. Matplotlib is used for creating static, animated, and interactive visualizations. Import yfinance as YF. Imports the yfinance library, aliasing it as YF. yfinance is used for fetching financial data. From sklearn. Model_selection import train_test_split. Imports the train_test_split function from the scikit-learn library. This function is used to split data into training and testing sets. From sklearn, preprocessing import min-max scalar, imports the min-max scalar class from the scikit-learn library. This class is used to scale numerical features to a specific range, usually 0 to 1. From keras, models import sequential, imports the sequential class from the keras library. This class is used to create a sequential model, which is a linear stack of layers. From keras, layers import dense, LSTM, imports the dense and LSTM layers from the keras library. Dense layers are fully connected layers, while LSTM layers are long short-term memory layers, commonly used for time series data. Functions. Defines a function get_stock_data that takes a ticker symbol, start date, and end date as input. Uses YF, download to fetch stock data for the specified ticker between the given dates. Returns the fetched data. Note, the remaining functions would typically involve data preprocessing, model training, prediction, and visualization, but their exact implementation depends on the specific approach chosen. Main execution. Checks if the script is being run directly, not imported as a module. Sets the ticker, start date, and end date for data acquisition. Calls get_stock_data to fetch data. Calls preprocess_data to preprocess the data, assuming this function exists. Calls train_model to train a model, assuming this function exists. Calls predict to make predictions, assuming this function exists. Calls visualize to visualize the results, assuming this function exists. Remember, this is a basic outline. The actual code would involve more complex logic, error handling, and potentially additional features. Would you like to delve deeper into a specific function or part